looking at the sun in 304 angstroms from halfway across the room. We see no sunspots. Bright active region rotating toward the Earth-facing portion of the disk. And an odd crown prominence-like feature revealed to us in our comments. Thanks, Anomalous Howard. Here's your 304 angstroms view complete with magnetic field lines. And here's the solar disk in 193 angstroms. We see that Earth-facing coronal hole there. Still yet to produce a sustained Sun-to-Earth magnetic connection, keeping the risk for earthquakes high, as we are still in a 7+ magnitude earthquake drought. Now, let's talk about stereo A and B. Regular viewers are probably aware that we've got a satellite 1/3 of the way around the sun on each side, enabling us to have a 360-degree view of the sun. Stereo A stands for ahead, stereo B stands for behind. We'll leave links to this if you want to read up on the website about where they are, etc. Now here's another site in the same web ring here that allows you to get images. And we're just going to take a quick look here at their 171 angstroms view, because we saw something odd on the stereo A last night. Now, not to be confused with a sunspot, probably something more like a crown prominence. See this bright spot right here, inside of the North Pole coronal hole. Now, we don't usually see bright spots inside of coronal holes. Let's just look at a few more images here to see how long this thing lasted. This particular one is from 2209. This does show magnetic looping, like you would see with a sunspot. So the best guess is that it is a magnetically active region. And here's another view here from the next day. So it looks like this thing lasted maybe about 10 hours, 12 hours or so, because now you can see it's dissipated. And here's another image in the middle, about 4 hours earlier than the previous one. Interesting crown prominence. Could have something to do with sunspot cycles. Moving on. Also, we will leave links to the Twitter conversation that was shown to us by Anomalous Howard. So there's that. And there's a conversation about it, talking about where sunspots occur and so on. So we'll leave links to Twitter also, even though we don't have a Twitter account. Next, how about a little solar wind in real time? So we see the BZ has just recently dropped into the negative territory here. These extreme BZ angles like this are associated with earthquake risk, as well as a 180-degree phi angle, which we do not see. Now, we've seen a recent uptick in the solar wind density here. Looks like it's about 8 protons per cubic centimeter. And that is often the predecessor to an increased solar wind speed, which we also see here a slight increase. Coronal hole wind stream coming in, but not a very big uptick. Look at some more data on spaceweathernews.com here. X-ray flux remains flatlined. Still waiting that 180-degree phi angle from that coronal hole. See wild fluctuations in the BTBZ there on both instruments, the ACE and the Discover. Magnetometer's gone into a little hiccup there. We'll be looking at the Gong 2 to see what will happen next. And the KP index is at 2. Here's your Cygnets forecast. That is through February 7th. I would note that the Parker Solar Probe is beginning its second dive into the corona. Electron flux, little perturbations there. Keeping an eye on that too. Charging hazards are now minimal. And the F2 layer is pretty heavily charged, actually. See that 12 megahertz layer? It's actually more charged than it even was about 5 minutes ago. So, F2 layer is charging up. There's going to be a large disparity between this highly discharged area and this incoming charged region. And there are your auroral forecasts. Pretty significant auroras at both poles. Here's the Gong 2 information, showing us the magnetic environment from 2 hours and 2 minutes ago. And we are expecting a spike in the magnetometer at any moment here because of the transition from this region into this more direct field force line region here. So that'll be something to look at throughout the day. You can probably figure out when that happens just by looking at the GOES magnetometer. Next, we've got geospace magnetosphere movies. Here's the velocity. We do see some high velocity regions there, especially on the equatorial plane view and then on the meridional plane view near the magnetotail. So there's some magnetohydrodynamic instability going on there, as that increased velocity is not caused by the solar wind speed alone, but by instability in the magnetosphere. Here's the density. You should see some similar, not similar, but some related perturbations associated with that high velocity. And we do indeed see some increased density there in the magnetotail and on the dawn and dusk side of the equatorial plane. Let that play through. You also see some lower density solar wind coming in there from the left. Keep in mind, on this view, the white is low density and the navy blue is the high density. Here's the pressure. Should show some similar magnetic perturbations here. Let that play through one more time. Thanks to the University of Michigan. Next, let's look at the view from the poles to see how those magnetic perturbations translate to ground magnetic perturbations, if at all. We're going to see some big increases here in the changes in magnetic fields. Let's look at it from this perspective. And we are seeing a verification of what the world magnetic models say here, as the planet has two north poles. The one over Canada being distinctly weaker, something like 1/10 or 1/9 the power of the one over Siberia. Let that play through once more. Also keep in mind, the South Pole seems to be creeping toward the Indian Ocean. Earthquake report coming from quakes.globalincidentmap.com. Going back 12 hours, we see an Indonesian quake at a 5.0, which, by the way, is right in the warning area that we've been citing for the last few days. Dominica gets a 3.4 at depth. Colombia gets a 4.4 at depth, also in the warning area, as we did warn for Western South America, as well as the area north and east of Australia. 4.7 in New Zealand at depth. See, now that's more of a concerning quake there, with the high population of New Zealand and so on. That's the kind of quake that leads to a greater quake at the surface. And just to reiterate, the warning area is right along this plate boundary. So New Zealand should remain on alert for, well, anything up to a 7 really, but something over a 5, just based on that 196-kilometer deep quake. Another quake in Indonesia at a 4.8 magnitude. And a 5.4 at the Philippines at depth. So pretty much seeing a lull in earthquakes here. And again, just to reiterate, these are the worst areas where it wouldn't be surprising to see a 7 plus magnitude quake. More like this. Volcanoes are still going off. Shivaluch, 15,000-foot ash plume there. Dukono, 7,000-foot ash plume. Fuego, 17,000-foot ash plume, so I think that's an uptick. Revenador, 16,000-foot ash plume. Sabancaya, sporadic puffs of volcanic ash. Planchon Peteroa, 17,000-foot ash plume and a 19,000-foot ash plume. Earthquakes down, volcanoes up. How about an article about pot from medicalexpress.com? Now, many people are very familiar with studies showing marijuana smoking lowers testosterone. Well, how about this article? Linked with higher sperm concentrations. We'll leave links to the interesting article. The study also found that among marijuana smokers, greater use was associated with higher serum testosterone levels. Well, it obviously doesn't lower and raise testosterone, does it? Next, we got an article about the Box Nebula. An electric universe people should be very familiar with this one. One of the most obvious electrical structures in the universe that we can see, at least. I mean, 90-degree angles like this are not associated with gravitational accretion, folks. They're associated with electromagnetic fields. And this particular article is about highly collimated jets. Newly discovered, not surprising to anybody who's familiar with the electric universe, theory of everything. This article led us down a rabbit hole that we're going to share part of with you. We'll leave links to it. Now, that particular study was done by Apache Point Observatory, so we decided to check out their page. It's a nice page. It's a little bit archaic looking, but they're doing some good work over there, so you gotta give them a pass on that. If you scroll down to the bottom, you see where it says public information. Well, if you want to be a citizen scientist, do some actual astronomy work, click on this thing right here that says Galaxy Zoo. You see that link? Click on it. Now, you don't even have to create a login to do the science, but let's just give you a quick idea of what this is. It's arguably the world's best-known online citizen science project, and is certainly the one with the largest number of publications based on citizen scientists' input. Their success inspired the creation of the Zooniverse, hosting project using the same techniques across many research areas. Zooniverse.org. So, you want to help do some real astronomy science? Check it out. Click on Get Started. Now, the reason this is a thing is because We have too many galaxies. There are billions upon billions upon billions of galaxies. And really, there's too much data in order to crunch. Some of it requires a visual analysis. That's where you come in. So, here's some real science going on. Now, you see this galaxy here? You're looking at it kind of on an edgewise perspective. So, it'll ask you questions. Is it simply smooth, rounded, with no sign of a disk? No, it looks like a disk, so you click on that. You say next. Could it be viewed edge-on? Yes, it's an edge-on disk. Does it have a bulge at its center? I don't think so. Click on that. Is the galaxy merging? Doesn't really appear to be merging or disturbed in any way. Do you see any of these rare features? A ring, a lens, arc, irregular, dust lane, overlapping. Nothing unusual. And now we're on to another one. See, we just did real science there. So if you want to help out crunching the data on what's going on with galaxies, help to classify them on Zooniverse.org. Let's go back to the sun at 171 angstroms. Thanks for viewing, everybody. Thanks, subscribers. Thanks to our patrons at Patreon and the people who've donated over PayPal. It means a lot, and it's going to help our operation to advance and grow and get more hardware and do more science. So thanks again. We'll be doing it all again tomorrow, possibly even later today. Now remember, when you're staring at active regions in 171 angstroms, don't drink. And if you drink, stare at active regions in 171 angstroms anyway. Just don't drive.